Why the sun is the only star that's burning? Well, let's put a pin in that thought for a moment. Picture yourself standing under the night sky, marveling at the twinkling stars. A common misconception is that those stars are merely glowing objects like decorative lights strung across the vast expanse of the universe. But in reality, each one of those stars, including our very own sun, is a blazing furnace, a powerhouse of energy. Now let's unpick this misconception a bit. You see, our sun is not the only star that's burning. Instead, it's one among billions of stars that dot the universe, each one burning as fiercely as the next. The only difference is that our sun is the closest to us, making it appear as the brightest and most prominent star in our sky. The reason all these stars, including the sun, shine so brightly is due to a process called nuclear fusion. This process takes place at the very heart of the stars, where the pressure and temperature are unimaginably high. Here, hydrogen atoms are squeezed together so tightly that they fuse to form helium, releasing a tremendous amount of energy. That's the secret behind the stars' shine. But here's a fun fact. Did you know that the light from the sun that reaches us is actually thousands of years old? That's right. The energy produced by nuclear fusion in the sun's core takes a long time to reach the surface and then travel the 93 million miles to Earth. So every time you feel the warmth of the sun on your face, you're experiencing a piece of history, a bit of sunshine that was created thousands of years ago. So if you ever thought you were alone under the only burning star, think again. But how does this celestial furnace work? Stay with me. The sun, like other stars, is a nuclear powerhouse. Now you might be wondering, what does that mean? Well, let's delve into the concept of nuclear fusion, the process that powers the sun, in a way that's easy for all of us to understand. Imagine millions upon millions of tiny particles, each so small that they're invisible to the naked eye. These particles are hydrogen atoms, the most abundant element in the universe, and they're packed into the core of the sun under intense heat and pressure. Here's where the magic happens. These hydrogen atoms, driven by the immense pressure and temperature, start to collide with each other. And when they do, they don't just bounce off each other like billiard balls. No, they combine to form a new element, helium. This process, my friends, is called nuclear fusion. It's a bit like building a Lego tower, where individual Lego bricks represent hydrogen atoms. You start with 4 separate bricks, smash them together, and end up with a new, bigger brick. That's your helium atom. But here's the kicker. This new helium atom doesn't weigh as much as the 4 hydrogen atoms that formed it. Some of the mass is lost during the fusion process, but don't worry, it doesn't just disappear. No, it gets transformed into energy, following the famous equation from our friend Einstein, E=mc². So what happens to this energy? It gets released as light and heat, radiating out from the sun's core, journeying towards the sun's surface, and then out into space. This is the sunlight that warms our planet, drives our climate, and powers photosynthesis in plants. In essence, the sun is a gigantic nuclear reactor, churning out energy day after day. But what is the result of all this energy production? Well, that's a story for another scene. Stay curious and keep exploring the wonders of our universe. Now, imagine this. Every second, the sun produces enough energy to power human civilization for almost 500,000 years. Let's dive deeper into the sun's remarkable energy production. At its very core, the sun is a gigantic nuclear furnace, where hydrogen atoms collide at high speeds, driven by the intense heat and pressure. In a process known as nuclear fusion, these hydrogen atoms combine to form helium. This fusion process releases an enormous amount of energy in the form of light and heat. This energy then embarks on a fascinating journey. From the core, it moves outward through a region called the radiative zone, where it bounces around like a pinball for thousands of years before reaching the convective zone. Here, the energy is carried by giant currents of hot gas, rising and falling like boiling soup in a pot. Eventually, this energy makes its way to the sun's surface, the photosphere, from where it radiates into space as sunlight. This light travels 93 million miles in just over 8 minutes to reach us here on Earth. But remember, the sun isn't just a one-trick pony. It doesn't only produce light and heat, it also emits a steady stream of charged particles known as the solar wind, which extends far beyond the furthest planets in our solar system. These particles can cause beautiful auroras when they interact with our planet's magnetic field. And let's not forget, this energy production process isn't a one-time gig. The sun has been burning for about 5 billion years, and scientists predict it has enough fuel to continue for another 5 billion. That's 10 billion years of consistent, uninterrupted energy production. The sheer scale of the sun's energy production is mind-boggling, isn't it? But how does it affect us here on Earth? You may not realize it, but every moment of your life is powered by the sun's energy. A bold statement, wouldn't you say? But let's dive into it a bit more, shall we? The sun, our nearest star, is a ceaseless generator of heat and light. This energy, radiating out in all directions, travels 93 million miles across the vast emptiness of space to reach our planet Earth. And it's this energy that sets the stage for life as we know it. Now consider the weather patterns. The sun's warmth doesn't just make for a nice day at the beach. It's the driving force behind our planet's climate and weather. The sun heats the Earth unevenly, creating areas of high and low pressure. These pressure differences cause winds which move the heat around the planet. The sun's energy also evaporates water from the oceans, lakes, and rivers, leading to cloud formation and ultimately precipitation. This complex dance of heat, wind, and water creates the diverse climates and weather patterns we experience every day. But the sun's influence doesn't end with the weather. It also fuels a vital process known as photosynthesis. In this remarkable act of nature, plants, algae, and some bacteria capture sunlight and convert it into food. This process not only sustains these organisms, but also produces oxygen as a byproduct. That's right. The oxygen we breathe is a gift from the sun, delivered by the greenery around us. And let's not forget, the sun's energy also supports human activities. From growing our food to powering our homes, solar energy is integral to our way of life. Even fossil fuels, like coal and oil, owe their existence to the sun. They are, after all, ancient sunlight, stored in the form of carbon-rich plants and animals that lived millions of years ago. So the next time you step outside on a sunny day, remember, you're experiencing the incredible power of our sun, the star that makes life on Earth possible. So, why is the sun the only star that's burning? Well, it isn't. In fact, it's far from it. The sun, our beloved source of warmth and light, is but one star among countless others in the cosmos. It's just that it happens to be our closest celestial neighbor, making its heat and light not just visible, but absolutely essential to life as we know it on Earth. But let's not forget about our distant stellar kin. Other stars scattered across the universe are also burning brightly, tirelessly, producing heat and light much like our own sun. They're just too far away for us to see without a little help from our trusty telescopes.